Pericles, to give the world the most remarkable piece of architecture in all of Greek antiquity, the Parthenon.
Pericles decided to rebuild the Parthenon on the Acropolis, using the crumbling foundations of an older Athenian temple. It would take thousands of laborers and skilled craftsmen to create this magnificent temple, and it would cost more than any building the Greeks had ever engineered, 30 million drachmas, in our terms, billions of dollars.
That's an amazing amount, but keep in mind that was a huge state enterprise.
Construction on the gargantuan building project began in 447 BC. The Parthenon was to be about 2/3 the length of a football field. Its outer dimensions, 228 feet long by 101 feet wide. The first challenge was to cleave the marble from a mountain quarry 10 miles away. In all, about 30,000 tons of the fine white stone would be needed. In the quarry, workers used the natural cracks of the stone to separate giant marble slabs from the mountainside.
The first step is to locate these cracks and calculate if this piece of marble is sufficient for my specific purpose. The second step is to put within these cracks both horizontal cracks and vertical cracks, wedges, iron wedges. Why? Because an enormous energy was given by hammering all these wedges simultaneously, so that the brittleness of the material makes further cracking.
Once the giant slabs were ready, gangs of men used levers, ropes, and pulleys to maneuver the marble and prepare the stone for transportation to the Acropolis. But accidents often happened.
There was an enormous risk that this big block would slide further on, killing people underneath.
But cutting and transporting the marble from the side of the mountain was only half the battle in the construction of the Parthenon. Engineers now had to answer the question of how to lift these 10-ton marble behemoths and erect the greatest temple the world had ever seen. The columns provide the main support for the structure. Each column consisted of 11 separate drums, stacked one on top of the other like checkers. They were carved so that they would perfectly fit when laid together in a column. To do this, the top of each drum was divided into 4 concentric circles, with each ring either smoothed or roughed out, depending on the amount of grip needed to interlock with the next drum. In the center of each drum, masons cut a rectangular notch measuring about 4 to 6 inches square and 3 to 4 inches deep. Carpenters then inserted wooden plugs into the notches, which served to align and center each drum with the one above it. The next challenge was in lifting the enormously heavy drums, especially those for the upper sections of the columns. A single column of the Parthenon could weigh between 63 and 119 tons.
A crane is an extremely simple device. You have just a boom, and then you have a series of pulleys, which, as we know, just give you the possibility of taking up a weight of, say, 10 tons by pulling down only 100 kilos.
Engineers attach the stone to the crane in one of several ways. The method most often used was to tie the end of the rope to the top part of a metal S-hook, fasten shorter ropes to the bottom of the hook, and then loop these around small protruding knobs called bosses that had been left uncut from the marble for this very purpose. Typically, 4 bosses would be left surrounding the drum or stone block, evenly distributing the force needed to hoist the object. The walls enclosing interior spaces had to be laid down with extreme precision, since the builders did not use mortar. To hold the ends of each block together, builders hollowed out the ends in a double T design. Then iron rods were inserted to clamp them together. After the columns and blocks were put in place, The bosses used to lift them were chipped off and smoothed over.
There's a saying that there are no straight lines in the Parthenon. Now, what's meant by this is that the architects incorporated a series of sort of optical illusions when they built it. It starts with the stairs, goes up through the columns, all the way up to the top of the building, the pediment, that triangular element at the top. So let's take a look at the stairs. They seem to be straight, but no, closer look, they bow in the center and they go back down at the end. Now this conceit, if you will, continues right up to the columns. This column is of the Doric order. There's no base. It seems to grow right up out of the stone. Each column has 20 flutes, which makes the column sort of undulate as you look around it. And then the column bows out in the center and bows back up at the top. This is a process called entasis.
Such long lines, which are more or less at the level of your horizon, tend to curve. So in order to extinguish this effect, they curve them the other way. So the result, again, is more harmonious, and you see it as being straight. Because if it was all straight, perfect, right angles, then you will see it like that.
The Parthenon's main function was to provide shelter for the monumental statue of Athena.